Hello everyone, very good morning all of you. How are you all? I hope now already everyone joined and we can start the class, right? Hi, everyone is waiting here. Yes, I am here now. I am live now. Tell your friends that yes, ma'am is live now. They can join and we can start the revision. All of you are fine. So all of you are ready to do the division of DBMS unit 4, that is DBMS. Right? Yes. Are you excited? As you all know that DBMS is our favorite subject and definitely we will get a good score in DBMS. We have to get it. Right? All are ready? And revision means not only my revision. Revision is your revision. It's not my revision, it's your revision, and you have to tell me what is the concept, what to do, how to do. I will only talk, I will only go. No, it's the time to be ready with your chat box, because here only you can chat with me. In Unacademy you can talk with me, but here you can only chat with me. So be ready to type your answer. And those who will be the first, just see that yes, who are coming fast. Yes, good morning everyone, very good morning. All are here. Irudhya, new, Mayuri, Mumtaz, Chandra, Chandrika, Udari, Ammu, Preeti, Lekka, Jay. All are here. Good morning, good morning. So let's start. Here we are doing this CS revision. As in DBMS, what are the topics you thought that yes, these are the important topics coming in exam? First of all, write down that. Quickly write down that what are the important topic we should learn. मैम हर एक यूनिट पे आप जो टॉपिक्स रिवाइज करवा रहे हैं उनने काफ़ी है करने को? काफ़ी कुछ भी नहीं है, उसमें बहुत कुछ है, और भी बहुत कुछ है. काफ़ी कभी एवरीथिंग नथिंग एंड. ओके, इट्स ए नेवर एंडिंग, इट्स ए सी, but we are trying to focus on the important one. What are the most important one? I can tell you one thing, that whatever topic we are doing here, from there you will get definitely confirm question will be there. These are the area from where you will get the confirm question. Yes, now everyone is typing here what are the common area and important area of DBMS. Yes, ER diagram. First of all, in DBMS, ER diagram, normalization, functional dependency. First chapter is the most important chapter, that is functional dependency chapter. From here you can get 2 to 10 marks confirm, at least minimum to maximum 10 marks. And functional dependency is a conceptual area from where always question are coming, and it's a must do topic, must do. You cannot go for exam without this. Next thing is the ER diagram. ER diagram also very important. From ER diagram also you can get 2 to 10 question. This is also the next important question. Deadlock is not coming under DBMS. Deadlock is coming under operating system. Deadlock is under operating system. We will do it tomorrow. Okay, deadlock is not that much coming under DBMS. Next thing is the SQL and relational algebra. This is the next important topic, SQL and relational algebra. From this also you can get 2 to 10 marks question, because DBMS is the subject from where last 3 years, if you are doing the analysis of last 3 to 4 years, in 2019 December also there was the question from functional dependency, 10 marks question was there. In 2020 also there was the question for SQL. They asked the question on SQL. 2022 they asked the question on relational algebra. Means in DBMS, DBMS is a chapter, is a subject from where high chances there you can get the 10 marks question, and it's a very much scoring area, very much scoring area. Cardinality, participation, everything is coming under year diagram. Under year diagram these are coming, right? So let's start. And those who are planning to take the subscription, if you are planning for the next exam, then definitely this is a good offer for you. Now it is going on, and today is the last day, 9th is the last day. If you are taking 6 months, you will get 1 month extra. If you are taking 12 months, you will get 4 months extra. This is very good offer. Use my referral code Priyanka C Live, PRIYANKA CLIVE. This is my referral code. Using this referral code you will get more 10% off, more 10% discount. That will be very much beneficial for you. So tell me, first of all, in functional dependency you have to understand how to determine which dependency holds and which dependency not hold. Tell me the first one, A implies B, is it holds or not? What do you think? What do you think? Is it holding or not? A implies B. Is it holding or not? And how to understand this? Which dependency holds and which dependency not holds? Yes, everyone is telling no. Can you tell me why? Everyone is telling no. Can you tell me why? Why not? Everyone is telling that A implies B is not holding here. Why it's not holding? Why? How to understand that why it's not holding? Why? I am asking why. Same have same in other C column. C column, where what it is doing in C column? We have to check B. Rajkumar, A implies A1 implies B1 B2. Yes, very good Rajkumar, because the reason is this one. When I am telling that A implies B, then each and every value for a specific value of A in the B column there will be the exact same value. Here you can see A1 is referencing to B1, and here A1 is referencing to B2. That is creating a ambiguity, and it's not exist, because when dependency exists then this type of dependency cannot be there. Here should be, instead of B2, here also should be B1. Here also should be B1. For A2 that is correct, for A3 also it's correct, A4 also it's correct, A5 also it's correct, but problem is with A1. So easy way is that first of all always check the right hand side. How to check? First of all check the right hand side, all the values. Is there any repeating value? If there is no repeating value, then no problem. When there are some repeating value, for that repetition in the left side all the values should be also same values. If these are not same values, then dependency does not exist. Now tell me, out of the remaining, which one is holding here? Just tell me which one is holding here out of these all. Which one is holding here? Which one is holding out of this all? A5 B3, yes, no problem. For A5 B3, see that here it is like that. A3 is a student, his father is also B3. A5 is a student, his father is also B3. That is no problem, because maybe they are all the siblings, they both are siblings, and both are reading in same class, and they both have the same father, that is B3. That is okay. But here A1 have father B1 and A1 father is B2. That is not possible, right? There is only one child and it have a father, so she or he have a father, his name is B1, and A1 have a father, that name is B2. It's not possible. That is the reason. This is the reason. Got it? Yes, everyone is telling here A implies B, D is holding only. A implies D is only holding. Yes, all of you are correct. Only A implies D holds here. Other than that, any one is not holding, because everyone is creating problem. For A implies D, if you saw that here A1 and A1 both are D1. That's why these are correct. Other than that, all values are not, any one is not repeating. When in the right hand side there is no repetition, no problem. No problem. If there is repetition, then I have to check in the left hand side, is it referencing to same value? Is it referencing to same value? If it is, then no problem. Otherwise, no. Udari, A implies C holds. No, A implies C is also not holding. For A1, here is C1. For A1, here is C2. It will not hold. A1, father name is C1. And A1 father's name is C2. How it is possible? Think like this way. A1 father's name is C1. A1 father's name is C2. Is it possible? It is not possible, and that's why A implies C will not hold. Only A implies D will hold. Bushaira. You are telling A to D. A to D, that is holding. That is correct. A to D is holding. D to A. D to A will not hold. D to A is just opposite. See that D to A, same thing, same problem is here. D1, that is okay. But for D2, here for D2, A2. Here for D2, A3. How it is possible? That's why it is not possible. That's why this will be not possible. Got it? That is the reason. Always check the right hand side. In the left hand side, if there are, sorry, I was telling right hand side, right? Sorry. It is the left hand side. First of all, sometimes in left right also I am doing mistake now. Left hand side, I have to check the left hand side. Is there any repeating value? If there is any repeating value, then I have to check in the right hand side, that if the right hand side also there are same values, then no problem. Otherwise, problem is there. Okay. Left hand side we have to check. By mistake I told that right hand side. Right hand side is there for candidate key. Yes. Now tell me which one is correct here. Which one is correct here? R, A, B, C having the tuple, this one, these are the tuples. Now options are given here. Which of the functional dependencies? Which one is the correct? All of you tell me the answer. Yes, answers are coming. A, B. Which one is correct? You did not see that. It does not hold. Does not. Here is a not. Here is a not. Not able to view. Why? Why not? Here is a not. Here is a not, guys. So not, be careful about the not in the question, otherwise you have to see the not qualified. If you don't want to see the not qualified, then you have to see that. All of you are writing B. Yes, those who are writing A, they are doing mistake. Rahul is wrong, and Mumtaz is also wrong. Mumtaz and Rahul. So here which one is not holding? B, C implies A is not holding because 2, 3 together. Here also 2, 3 together. Here is 1, but here is 4. So it's creating a problem. Now which one is super key, candidate key and primary key? What is called the super key? What is primary key? And what is candidate key? Super key is that means key. What is a key? First of all, we have to think what is key. Key means that which one can identify all other attribute of a table. Key is that one which one can identify all other attribute in a table. Now, from the key, which one is the candidate key? First of all, if you understand the candidate key, then it will be easy to understand super key also. Candidate key is that one, it is the minimal set. The minimal set in the table, which one can identify all other attribute. If it is possible by only one attribute, then it's okay. Otherwise, maybe I have to combine two attributes together. They together is able to identify. How? Employee ID. If the employee ID is unique, then employee ID can identify every other one, like employee name, employee address, employee age, employee phone number. Everything can be identified. Maybe here is no employee name. Maybe there is a Aadhaar card. So Aadhaar card ID is also through the Aadhaar card ID you can identify. But when I am taking a roll number of a student throughout the school. Now in each and every school each and every class there is same roll number. If I am taking roll number 1 only, it cannot be identify any specific student. Because roll number 1 can be there in class 1 also, class 2 also, class 3 also, everywhere there is roll number. So what I have to do? I have to take the roll number plus the class also, and if required plus the section also. Then roll number, class plus section can identify a specific student. If I am telling roll number 1 of class 2 of section A, that will be a single person only. So this is my candidate key then, and this candidate key is making three attribute together is able to identify a student specifically. Then we can say it is candidate key. Now if I am dividing it only with roll number and class, then they cannot identify, because in section A also there is roll number, in section 2 also there is roll number. It cannot be identified. But if I am doing like that, ki Aadhaar card ID that is common throughout the India. Each and every person have separate Aadhaar card ID. So Aadhaar card ID can be identified everyone separately, and that is only one enough. So it is called candidate key when you cannot split it more. Only together only it can be identified. That is the minimal set. Now if with the roll number, class and section, if I am adding something extra like name, this is called the super key. Why? Because these three attributes together can identify a student. If I am adding something extra, that is a super key. Because without adding name also I can identify the student, and that's why it will be now super key. So what is a super key? A super key is that candidate key plus more than that, candidate key plus something extra attribute. Whenever I am adding, it can be one attribute, it can be two attribute, it can be three attribute. That is called a super key. Now which one is a primary key? Primary key is that out of all the candidate key in a table there can be multiple candidate key also. Like a phone number can be candidate key, Aadhaar card ID can be a candidate key, roll number, class plus section, that is also can be a candidate key. So out of them we have to decide that which one will be my primary key as per my requirement. So as per our requirement, we are choosing any one of them as a primary key. That is just like a prime minister. All the candidates who are selected in election, out of them any one of them I am choosing, that is called a primary key. And this is the concept of super key, primary key and candidate key. I hope it is clear. So what I told, it's clear. Now do the question. Now do this question. Tell me what will be the answer of this question. Just see the question very carefully, otherwise you will do the mistake. See the question very carefully. I am hiding myself. Yes, you can choose out of the candidate key, any one of them you can choose as a primary key. Out of, if there are 2 candidate key, 3 candidate key, out of them any one will be the primary key that you can choose. Options are given. Options are given here. You have to answer with the option. Which one is the correct answer? As per the option you have to answer me. And now I am back. Yes, answers are coming. So which one is the correct answer? Let me check. Yes, all are giving the answer now. Which one is the correct here? Option 3. Achha, let me see. It is asking you if different symbol they are definitely not equal, then which one could not be a candidate key? Which one could not be a candidate key? It is also again the not. Which one could not be a candidate key? See that. Which one could not be a candidate key? First of all, I have to check that, see, here is 1B, here is BC, right? Now I will check it that B can be a candidate key or not. How to check it? From the B, you have to check like this way, that B implies A, B implies C and B implies D. Is it holding or not? If these all are holding, then B can be a candidate key, right? How to check? See that B implies A, if I am checking, all the values are different, right? There is no repetition in B. Left hand side, B1, B3, B2, there is no repetition. As there is no repetition, means what can be? It is also correct, this is also correct, this is also correct. Means definitely B is my candidate key. B is the candidate key. So when B is candidate key, then BC cannot be the candidate key, because why BC cannot be the candidate key? Why BC cannot be the candidate key? Why? What do you think? Why BC cannot be the candidate key? Why? Why? Answer me in the chat box. Why BC cannot be the candidate key? Yes, because it is a super key. It is a super key. That's why. Because BC is the super key, it cannot be the candidate key. So option 2 cannot be the candidate key, and here is only option 2. So it will be the answer. AD can be candidate key, CD can be candidate key. And for this question only your concept will be clear, that sometimes students are counting the number of attribute. Sometimes students are thinking that as B is the only one attribute here, so that's why it will be the candidate key. Here two attribute, that's why it cannot be. Here also it cannot be. Don't do that mistake. B is itself minimal, that's why it is also possible. A and D together is doing it. Only A cannot do it. Only D also cannot do it. That's why it is also candidate key. Only C or only D cannot do it. That's why it is also candidate key. So they all are candidate key, but BC is not, because B is already candidate key. BC is the super key. So your answer will be this one. Option 3 is the correct answer. Clear? Yes. Now try to identify the candidate key now when this type of question are given. Already we identify through the table. Through the table how to identify candidate key, this is the way. Now through this type of dependency how to identify the candidate key, now do it. Through the data or table how to do it, that we already understand. Now through the given dependency how to identify, what will be the answer? It was not. Why, Ammu, you are not checking? Could not be. Here was a not. Could not be the candidate key. The question was that. That's why I went away and I told you to watch that very carefully. It was could not be. Why you are not checking question very carefully? Always check question very carefully. Okay. Yes. So here all of you are giving correct answer and everyone know that yes, this is the way how. Yes. How to do it? Here it is U implies V and all are there. We will check. Here we have to check the right hand side. Previously in the table we checked the left hand side. Now we are checking the right hand side. In the right hand side, which one is not present? V present, X present, W present, U present. So U, V, which one is not present? Y and Z is not present. As YZ is not present, then YZ have to be the candidate key, means part of candidate key. Next we will check with YZ plus. YZ plus cannot determine anyone. Y can determine anyone. W, Y can determine W and Z cannot determine anyone. So it cannot be my candidate key. Now we will try to add one by one, and by adding one by one we will see that Y, U, Y, Z, it can identify everyone. Then U can be replaced with X, that way, and again X can be replaced with the next one, that is V. X can be replaced with V, and in that way we will get it all this. And within 1 second you can do the answer, because YZ is not in right hand side and it is only YZ everywhere. Here no YZ, here also no YZ, here also no YZ, and it will be the correct answer. Everyone know that. Yes. Now the next topic is normalization. How to do the normalization, what to do here, how to identify. First of all, in normalization, the easy way is that how to do it. Yes, it all candidate key. All candidate key are super key. No, candidate key plus something more is the super key. All candidate key plus something extra is the super key. Okay. Ma'am, can we go with the option also? Yes, definitely. With the option also you can go. That I told that YZ not in the Why is it have to be the part of candidate key? That's why here is only option. You can do it. It's done without doing anything. You can definitely we can go. Definitely within 1 second you can do it. Yes. Now come to the normalization. In normalization, what to do and where, how to understand. First of all, we are checking the BCNF here. Because when it is satisfying BCNF, then it will be automatically satisfy 3NF, 2NF and 1NF also. And if one is BCNF, then it will be already satisfied because BCNF is more constant. What is BCNF? BCNF is left hand side is candidate key or super key. That is the most important one. I will check only the left hand side, and here with the left hand side is the candidate key or super key. Then we will go for 3NF. In 3NF, what to check? If it is not in BCNF, then 3NF there will be the little bit less rule. What is the less rule? That left hand side and right hand side, when we are checking it, non-prime to non-prime not allowed. Here main concept is non-prime to non-prime will be not allowed. That is only, right? Yes. Acha, tell me. Now tell me. You have to write it down, everyone. Your revision. What to do for BCNF, what to do for 3NF, what to do for 2NF, and after that 1NF. How to do it? Write down in the comment box so that your revision will be done. How to identify? Yes, SK is the superset. Super key is the superset and candidate key is the subset. Candidate key is the minimal one. With the candidate key, if I am adding something extra, that is the super key. If A is my candidate key, with that if I am adding B, that is a super key. If I am adding C, this is also a super key. Yes. Yes, for BCNF we will check that left hand side should be candidate key or super key. Only this is the thing. Other than that, anything will be not allowed. For 3NF, what to do? Yes, for 3NF, non-prime to non-prime will be not allowed, and prime to non-prime, that will be also not allowed. But if right hand side is prime, that is allowed here. There is no problem. Now come to the 2NF. In 2NF, what to do? What to do? Yes, in 2NF, non-prime to non-prime, that is allowed, but prime to non-prime, that is not allowed. In 2NF, constraint is little bit less. Prime to non-prime, that is only not allowed, but non-prime to non-prime, this is allowed here. And in 1NF, everything is there, that is okay. In 1NF, mostly all of these are allowed, but multi-valued attribute will be not allowed, because as per the DBMS rule, we will not allow any multi-valued attribute. So that's why multi-valued attributes will be not allowed here. Other than that, everything will be allowed. Yes. No partial dependency and everything. Mostly in 1NF, everything is there. 4NF also checking the multi-valued. Right. 4NF is checking the multi-valued also. 1NF, normally everything are there. Yes, good. Very good, all of you. So your revision is done. Now tell me how to identify lossless and lossy. What to check for lossless and lossy? How to check lossless, lossy? Rahul, what you need explanation? Lossless. Which one you need explanation? Lossless and lossy. How to do? If we get original table, original relation, how to check? How to check? Is it a lossless or decomposition is lossless or lossy? After decompositions get same. How? What are the rule? Yes. Yes. First of all, first rule is that the relation R you are dividing into two parts, R1 and R2. Okay. Then there should be some common attribute. Means R1 intersection R2 cannot be phi. There should be some common attribute. It cannot be phi. After that, next one, number 2. Yes, very good. Otherwise, next one. Not phi, that is okay. Then what are the rule? That is okay. After that, next. Next, what to check? CK R1 R2. No. Next checking is R1 minus R2. R1 minus R2 or R2 minus R1. This is the next checking. Means what I am getting. I am showing you with the example. What to check here? Either R1 intersection R2 implies R1 minus R2 or R1 intersection R2 implies R2 minus R1. What is the meaning? The meaning is here. I am showing you the meaning here. You can see this question. This question is like here ABC divided into two parts, R1 and R2. It was ABC. This is divided into AB and BC. This was your R. This is R1 and this is R2. Now you can see R1 intersection R2 means what is the common? Common is B. So common is here R1 intersection R2, that is B here. Right? Now what to check? R1 intersection R2 implies R1 minus R2. So B implies A. Is it there? Are you able to find out any functional dependency? Which one was B implies A? Is it there? The functional dependency was there only. A implies B. B implies A was not there. Even also if you are doing closure, you will not get the B implies A. So this is not satisfying. Next one we will check. This one is not satisfying. This is the OR. OR means R1 intersection R2 implies R2 minus R1. Is it satisfying? See that here is B, implies BC minus AB. So BC minus AB is C. How to do it? From the first table, I will remove the common one. The common one is B. That's why it is A. So B implies A. Here it was B implies C. Is it there? B implies C is also not there. This is also not there. This is also not there. As these are not satisfying, that's why the decomposition is a lossy decomposition. Here you cannot, whenever you are joining, you cannot get the original one. That's why it will be a lossy decomposition. Is this clear? Is this clear why it is lossy? If any one of them is satisfying, either this one or this one, then it will be lossless. No loss. Otherwise, it will be lossy. Clear? I hope so. Yes. Okay, so here you can see after that this is the lossless, lossy. So next one is the how to check the dependency preserving. Any relation, is it dependency preserving or not? How to check it? For dependency preservance, same way we will check here. A relation is given R and this is given into R1 and R2. Two relation is divided. In R there are some functional dependency F. Here is F1, here is F2. So what to do? Actually before dividing only we should go for the closure. That is the F closure. After that definitely divide it. And then do the union. When you are doing the union, after doing the union, the closure, if you are getting the same one, then it is dependency preserving. Otherwise, it is not dependency preserving. See, here is an example. What is the example here? You can see R is A, B, C, D. This is divided into two parts, R1, ABC and R2, AD. Here the dependency was given A implies BC. This was the dependency given to you. Now from this one I will try to do the F closure. F closure means from here you will get A implies B and A implies C. Anything else are not coming. So I will divide it like this way. So A implies BC. It is only there, nothing else. Here there is no one. Here you can see, can you get anyone else? AD. Is it coming? Anything? No, nothing coming. Now if I am doing this union, I will get the dependency preserving or not? I will get it. Again I will get it because ABC is there. So I am getting the ABC only. So no problem. It is dependency preserving. That's why it will be dependency preserving. Clear? Is this clear how to check? Always remember to do the closure. Without closure, if you are dividing it, then it will be very problematic. Must do the closure. After that only divide. Then after that check it. If it is coming, then it is preserving. Otherwise, it's not preserving. I hope this is clear to everyone now. Okay, now do this question. Identify the primary key. Do this one. Quickly, everyone can do it. Very quickly, everyone can do it. After that, we will go to the next question. Yes, which one is the primary key here? Definitely A will be the primary key. Yes, definitely A is the primary key here, right? Yes, 3 option. Next one, identify the normal form. Which one is the normal form here? It is in which normal form? It is in which normal form? Yes, it is in 2NF. Sometimes students have a confusion that A implies D. They are telling that ma'am it is prime to non-prime, how it is 2NF. Don't do that mistake. This is not prime. This is the candidate key to non-prime. It is the whole candidate key. A is a whole candidate key. It is not a prime to non-prime. It is the whole A is the candidate key, and that's why candidate key to non-prime means when left hand side is candidate key, then it is actually in BCNF, right? So that's why this is the part means A implies D, don't be confused. Only when there is the more than one attribute, then only the prime concept will come. That is the part of candidate key. When only one attribute is there, there is no problem. You can do it, right? Next one is that after dividing R1 and R2, which one will be correct? After dividing answer after dividing, what will be the correct answer? Yes, option 4, that is R1 is in 3NF, because actually R1 will be in BCNF because both are candidate key. That's why actually it is in BCNF. And this is A implies D, D implies E. This part is okay, but in this part it is non-prime to non-prime, and that's why it will be not in 3NF, but this will be in 2NF. So answer will be this one. Now identify the redundant one. It is the part of minimal cover. How to find out the minimal cover? To find out the minimal cover, first of all we have to remove the redundancy. It can be some redundant attribute. It can be some redundant dependency also. So which one is redundant here? That is we have to check. Yes, answers are coming. Yes, A implies D. This is redundant here. A implies D is redundant here. And why it is redundant? Because if I am removing A implies D, after removing also, if I am doing A closure, then through the A closure I can get A, B, C. From the B, C I can get D, and from D I can get E. Without this also it can be identified by everyone, and that's why this will be the redundant one. So answer will be this one. Yes, all of you are correct. So now which one is the minimal cover? Which one is the minimal cover here? Yes, very easily. After removing A implies D, which one left? These are left. So A implies B, I can write like A implies B, A implies C, and remaining all are correct. This is the correct answer. Yes, now it is the concept of natural join. Tell me what will be the answer for this. And what actually we are doing in natural join. What actually we are doing in natural join, and what is the concept of natural join. So from last 40 minutes I am talking, but I can see only 8 like. So but here I can see in the live chat there are 33 learners. So other person you can dislike. If you really don't like it, then you can dislike. So press the dislike button please. If you think that yes, the class is not useful for me, then you can press the dislike button. But press it, something, whatever you want, it's your choice. From last 45 minutes it's already class is going on. No, it's already 50 minutes. So from last 50 minutes I am talking, but you did not press anything. So press a dislike. You can press the dislike. Yes, so here it is 1500, 1500 is here. So 50, why it will be the answer 1500? Because in natural joining, although we are taking the common one, Kavita, you are wrong, it is wrong answer. Because it is x, y and y, z, there is no dependency between y. Just it is given the same attribute, and never do the answer with same attribute. It can be different value also. Here is x, y. Here is yz. It can be some different value. Here is yz. It can be 1, 2, 3. It can be 4, 5, 6. So when it is like that, there is no common value. Although attribute name are same, but the value are not common, then it will work as Cartesian product. That's why as there are 50 and 30, the answer will be 50 multiply 30, because the question is asking you maximum number of tuple, and in the question it is not given like that key which one is superset, which one is subset, or this is the primary key, this is the foreign key. This type of any relation is not given. That's why those who are marking 1, it is totally wrong. Please clear your concept here. Natural join does not mean that always you will get the minimum one. When there is the superset and subset relationship, if it is given like that R1, here is XY, this Y is your super key, maybe this Y is your foreign key, and from this R2, YZ, this is your primary key, and it is referencing to this, then only we will go for this 30, as there is nothing mentioned here. So must clear your concept. Always before doing any join operation, it will do the Cartesian product. After that it will apply the filter. If the filter is working fine, then it will do it. Otherwise the answer will be as per the Cartesian product, and this is the correct answer. From wherever you learn this concept, this is a wrong concept. Please do the correction. It is a wrong concept. And if anyone is telling you this is answer 1, that is wrong. Official answer key, as per the official answer key also, it was rectified. I remember that because in December 2019 question it is, and that time it was a challenge, and that's why I remember in final answer key it was the final answer key, and conceptually also this is correct only. Okay, if asked minimum number of tuple, then answer will be 30. Yes, minimum can be 30. Yes, minimum can be. Yes, I was thinking that considering keys. No. Got it? Clear? Clear? The final answer key is this one only. Now, and that is the concept. Now the ER diagram. In ER diagram, these are the different types of attribute. What is key attribute, composite attribute, multi-valued attribute, and derived attribute. And relationship 1 to 1, 1 to many, many to 1, many to many. Tell me quickly. Which one is composite? Give an example of composite. Give an example of multi-valued. Give an example of derived attribute. Quickly, quickly. Give me the example. Example, I am waiting for your chat. Derive age, multi-valued phone number, composite first name, last name, name, that is first name and last name. Yes, good, very good. Composite means it can be address also, it can be name also, like first name and last name together is doing name, that is a composite one. Multi-valued attribute is phone number, because phone number have multiple values. Derived attribute is age, because age there is no specific attribute, through the date of birth only we are deriving it, and that's why it is called the derived attribute. All of you are correct. Very good, very good. So these are the some quick revision notes for you, because question are asking from here also, which how to represent entity set, relationship set, weak entity, weak relationship, attribute, composite attribute, multi-valued attribute, derived attribute, key attribute, partial depend, partial key. This is called the key constraint, total participation, 1 to 1, 1 to many, many to 1. This representation are also important according to the relation. And this is the question, do the answer. Do it. Yes, answer will be 3. Definitely you all are correct. Yes, everyone, 3 is the correct answer. Now what is participation and cardinality? This is very important. Participation means what is the minimum number of relationship an entity can participate. Minimum number, that is an employee, one employee can work in one department. Minimum, that is the participation. one department have no employee, 0 employee. It is possible because it is a new department. That's why it is possible that participation can be 0. Cardinality is always the maximum. Maximum means one employee can work maximum in one department. That's why maximum is also 1. But one department can have many employee, multiple employee. That's why cardinality is M here. And here, as this is the participation at least 1, that's why we are calling it total participation. When participation is 1, then we should say it is total participation, means it cannot be possible that any employee is not related to any department. For each and every employee there should be a entry of department, that is called total participation. And whenever we are writing one to many and many to one, here also a conceptual problem of most of the student. Right, see that cardinality 1 means actually what it is, that entity A is associated with at most one entity of B. That's why here it is cardinality 1. Cardinality M means the B is connected with at most many attributes of A. That's why it is many. And whenever we are drawing it, this will be many to one relationship. Don't do it one to many. One to many will be wrong, because this one will go this side and this many will come to this side, and that's why it will be many to one, not one to many. If you are doing one to many, that is wrong. It will be many to one. Be careful here. And with this key constraint, means this is the sign of the key constraint. When you see this sign, means here the cardinality is 1. Wherever the key constraint means, that is the cardinality is 1 here. It is also the identification of key constraint. So here you can see it is a question. From here actually this type of question can be asked, that one to many, many to one will be given to you, and how many minimum number of relation required. Before coming to this, I want to say one thing. Tell me, for one to one, where should I combine relationship? For one to many, where should I combine? And for many to one, where? And many to many. How many table will be required? What is the minimum number of table required for each and every one? For one to one, what to do? For one to many, what to do? For many to one, what to do? And for many to many, what to do? Whenever there is the ER diagram given to you and they will ask the minimum number of relation required, how to do it? Many to many, is it 2 table? Everyone, I am asking everyone. How many tables will be required? How to do? For 1 to 1, 2 table will be required, because relation will be merged with any one of them. Here also, here for both also 2 table will be required, because relation will be merged with the cardinality 1. Always remember, you can merge the relation with the table where cardinality equals to 1. where cardinality 1 with that side you can merge the table. But for many to many you require 3 table, because here there is no one cardinality 1, and that's why I need an extra table for relationship, and here it will be 3 table. And now here in the question, as you already given the answer for this question, 1 to many, this is the 1 to many. As it is 1 to many, that's why for both there will be only 2 table. But as this is the multi-valued attribute, that's why I need 1 extra. So that's why 2 plus 1, that is 3. For the multi-valued attribute, always we require a separate table, and it is the symbol of multi-valued attribute. That's why answer will be 3. Clear? Achha, this is the last question. Already 1 hour over, 1 hour 5 minutes is going on. I have to end the session. So this is the last question. How to do it? What will be the answer? Already we did the practice of SQL practice session. Already we did in the free class on Unacademy platform. Definitely you can watch that class. We did it. SQL is very important, and SQL you have to do it separately, because SQL concept is very important. Yes, everyone is correct here too. When I am deleting this 20 and 40, by deleting 20 will be deleted, and that's why this one is related, so this 20 will be also deleted. 35, this 35 is related, that's why this one will be also deleted. So ultimately the 30 and 35 and this will be deleted, but the 30, there is no one is 30, that's why it will be no deletion, and your answer will be this one. Priya Dash, Rahul, those who are marking 2, they are wrong, correct, but Priya Dash, you are wrong. Not only 30, 30, 35 and 20. 30, 35 will be also deleted, because whenever you are deleting this 20, then employee 35 will be also deleted, and that's why employee 35 is the manager here. That's why this one will be also deleted. So the both will be deleted here. That is the answer. Okay. So these are the ER diagram, and functional dependency is the most important chapter of DBMS. That's why we cover here. And one question you can do, this is the SQL question, you can do it, quickly do this. I am trying to end, but after that I am thinking, okay, let's do something more, something extra, so that it will be beneficial for the student. But not only this is not only sufficient. I will show you a class on Unacademy platform in my profile, where we did lots of SQL practice. Must watch that also. That is also the free class of SQL. Go to Unacademy platform, install Unacademy app. The free classes are, lots of free classes are there, and you can download the PDF. And even also today's PDF also you can get from the community. There in the Unacademy app there is the community. Follow my community, Priyanka Chatterjee. There I will post the PDF, today's PDF. Last 3 classes PDF also I have posted. Unit 1, Unit 2, Unit 3. All PDF are there, you can download, and today's PDF also I will upload. Yes, the answer will be, the total number is this one, and this is the answer. So just I am showing you something extra, that is what you can do in Unacademy platform, and this subscription will be very much helpful to you guys. And remember my referral code is Priyanka C Live. Don't go, because I want to show you something very important, those who are new, for them. PRIYANKACLIVE. This is my referral code. Using this referral code, you can get here 10% discount. With that, 6 month if you are taking, you will get 1 month extra. 12 month you will get 4 month extra. This is very beneficial for you. And today is the last day. Today is the last day of this offer, so you can take it. And there are the free classes what I want to show you. You can come to my profile. This is my profile, and whenever you are coming to the special class, you can see lots of special classes are there. And this is the class of SQL practice session. If you click on the class, you can see the SQL practice session, and here we did lots of SQL practice. And not only that, before that we did the revision also, PYQS series of unit 4, means that is the PYQS question practice. So each and every unit PYQS also is here. 2022 solution is here. So just visit my profile. It is free of cost. You can access everything, all the free classes, lots of free classes are there. It will be very much beneficial, and you can download the PDF also. That is also free of cost. Okay. So bye everyone. See you again tomorrow. Tomorrow is unit 5 operating system. We will do same time 10:30 AM. So please like,